Okay, first, if we are given the equation of this circle. So as I copy down the equation, I'm going to write it in the order by grouping my x terms together, leaving a space to complete the square, grouping my y terms together, leaving a space to complete the square, and then moving my constants over to the other side. So I'm going to subtract an 8 from both sides. Okay, now, when we look at this problem, what they tell us is we're going to have some circle, and at the point 5, 3, there's going to be a line that passes through, and we're looking for the equation of the line that passes through this given point that's going to be tangent to this given circle. So we can plot our given point. What we need to know, though, is what our circle looks like on this sketch. So we need to find its center. Okay, so in order to find the center, we're going to complete the square here. To complete the square, we look at our first degree terms coefficient. We're going to take half of that, and we're going to square it. So half of negative 6 is negative 3. Negative 3 squared is positive 9. Okay, so we're going to add 9 to both sides to maintain the balance of this equation. The whole point of doing this is it allows us to rewrite these three terms as a binomial square. The first term of that binomial is x, and the second term is half of this coefficient, so negative 3. Okay, we're then going to do the same thing with the y's. We're going to take half of our first degree terms coefficient, so half of negative 4 is negative 2. Negative 2 squared is a positive 4, so we're going to add 4 to both sides. Once again, it allows us to rewrite the left side as a binomial square. First term y, the second term is half of this, so a negative 2. And that's all equal to, and we just combine our terms here, negative 8 and positive 9, net you 1. 1 plus 4 gives you 5. So here's the equation of our circle. The information from this equation that we're going to use is the location of the center. So where is the center located for this circle? At the point 3, 2. So let's plot that point. So 3, 2, here's our center. And since the point of tangency is given, we can identify the actual circle itself is going to look something like this. Okay. Again, you can sketch it to see. And the line that we're going to find the equation for is going to be this tangent line through the given point 5, 3. Okay, so we have to go all the way back to chapter 1 to review or to look at the equation of a line. Okay. The equation of a line can be found by given any 2 points or by given a slope and a point. So we have a point. Is there any way to find either of those pieces of information, either another point or a slope? Julia?
We can find the slope between 5, 3 and 3, 2, and then take the negative reciprocal.
Okay, good. If we know what this slope is, the slope of our radius to that point of tangency, then we know that the tangent line, which is perpendicular to the radius, has to have a slope that's a negative reciprocal. So we can either take the rise over run, or the difference of the y's over difference of the x's, or we could simply count. And this is a small enough one, we could just count the slope. We move up how many? Up 1 and over 2. So our slope is 1 over 2, or 1/2, which means the slope of the negative reciprocal, the perpendicular line, is going to be negative 2 over 1, okay, which is just negative 2. So now we can write our equation for the line that has a slope of negative 2 and passes through the point 5, 3. And that's as easy as taking our slope-intercept form, plug in values for x, y, m, and solve for b. So our x-coordinate is 5. Our y-coordinate is 3. And our slope is negative 2. We can now solve for b here by just performing these operations. Add 10 to both sides, and we can solve for our y-intercept. The y-intercept is 13. So once we have our y-intercept and our slope, we can write the equation of our line, and that equation is y equals negative 2x plus our b value of 13. So here would be the equation of this line that passes through the given point and is tangent to that given circle.